Hello friends, the next nonlinear application of op-amp is peak detector using op-amp. This is a simple circuit. We'll be talking about two peak detectors. First, we'll be talking about positive peak detector, right? And then we'll be talking about negative peak detector. These circuits detect the last peak value. These circuits detect the last peak value of the input voltage and hold the output at that value. We will see that. So first let us talk about peak detector, positive peak detector. We have a simple voltage follower circuit like this. We have a very simple voltage follower circuit with diode connected at the output of op-amp, something like this. It's not exactly voltage follower, but circuit like this, and we connect a capacitor at the output terminal. This is V0, right? Now see it carefully. When input voltage is positive, diode is forward biased and capacitor gets on charging. So say take input voltage like this, right? This is the waveform of your say input voltage. Now let us see what will happen. When input voltage is positive, this voltage at output terminal of op-amp will be positive, diode will be forward biased. So when diode is forward biased, this behaves like a short circuit and your output will follow the input. So output will be same as input up to this point. But when the moment the input voltage start falling below this value from this peak value, the voltage across capacitor, which was this value now, that was output voltage, becomes more than this value. So voltage across capacitor is this much, that is peak value, and input voltage is falling below this. In that case, diode will be reverse biased. And when diode is reverse biased, it will behave like open circuit. When diode is going to reverse bias, when input starts falling, voltage across capacitor becomes more than this voltage and this becomes open circuited. So output voltage will be VC. So output voltage is last peak value which is held by the capacitor. Now till input voltage remains less than this voltage across capacitor, your output voltage will be same as voltage across capacitor. Now when input voltage again becomes more than the voltage of capacitor, when input voltage becomes more than voltage of capacitor, last voltage of capacitor, diode will be on. And when diode is on, your output voltage again starts following the input voltage and capacitor keeps on charging. And at this point, again, when input voltage starts falling below the capacitor voltage, diode will be opened again. And when diode is open circuited or off, output will be same as the last peak value. So what has happened? Your output of this circuit is following the input only up to peak value, and output or capacitor holds the last peak value of the input voltage. So that's why we call this as the positive peak detector. Now let us talk about negative peak detector. In negative peak detector, everything is similar. The only change is polarity of the diode, right? Let us see the second case now. In this case, your output voltage will be something, say initially this is time, not input, I'm sorry, this was output, this is time, right? Now suppose Your diode will be reverse biased during when input voltage is positive, so it will not be detecting the positive peak, but when input is negative, let us see that. Suppose input voltage waveform is like this, right? Input voltage waveform is like this. So when it is negative, it is closed. So output follows the input till input voltage is increasing and negative. But at this point, the input voltage starts falling. At this point, input voltage starts falling, becoming less negative. Right? Diode will be reverse biased because of the voltage of capacitor will be more negative than this. And if diode behaves like an open circuit, and this capacitor holds the last value till your input voltage becomes more negative than this. And when input voltage becomes more negative than this, diode is again turned on and output voltage follows the input. Again at next peak value, your diode is reverse bias, output is nothing but voltage across capacitor. Again when input voltage becomes more negative, output follows the input. Again when input voltage starts falling, capacitor holds the value. So this circuit detects the last negative peak value of the input voltage. Right? That is how the negative clipper will be working. This is a simple circuit, but there may be question in exam. They may be asking the function performed by the circuit, or they may be asking about the waveform. So, but this is small topic, but from understanding point of view, it is important. So, this is all about negative peak detector circuit.